Today we'll be discussing an interesting problem that was asked in your IIT exam 1981. This was asked in your 1981 IIT exam. So, which involves several concepts clubbed together. So, this problem caught my attention because it had an infinite series, and we'll be using definite integrals in order to solve this particular problem. And if you look at the problem, the given sequence is in HP, which is an harmonic progression. So this is the problem that we'll be discussing today. In order to solve this particular problem, we'll have to find the general term for this particular summation of the sequence. So in order to do that, let us simply observe the denominators. In your denominator, here you are having n plus 1 and here you are having n plus 2. Alright. So let me simply write it like your first term as n plus 1, just the denominator, and your second term as n plus 2. So in order to go from n plus 1 to n plus 2, all you have to do is simply add 1. So which is clearly an common difference in an arithmetic progression, which clearly states that denominators are in arithmetic progression. So we can simply imply that your reciprocals of your denominator are in HP, which is called as a harmonic progression. And harmonic progression is simply that your reciprocals of your arithmetic progression can be called as your harmonic progression. Alright. So yes, it is now, we just found out that it is an harmonic progression. Now let us find out how many terms are there in this particular HP. So in order to do it, I am going to find number of terms, or I am going to use the number of terms in an AP formula, because if you consider only denominator, we already saw that they are in AP, so we can use number of terms in an AP formula simply just to find the number of terms in that arithmetic progression. So your formula is L minus A by D plus 1, and your last term would be 6n, and your first term would be n plus 1, and your common difference would be 1 plus 1. So 6n minus n plus of minus 1, and then you'll be having your minus 1 over here. So your plus 1 minus 1 gets cancelled and you'll be having 5n, right? So you're having number of terms in this particular progression is 5n. Now coming back to the general term. So the general term for an HP is given by reciprocal of the general term of an AP, so which is A plus n minus 1 times G. So 1 upon A would be n plus 1. Now we can't use the same n. Since n is already taken, we'll have to use another variable. So let me write it as k minus 1 times your d is 1. So it is 1 upon n plus 1 plus k minus 1. So your plus 1 minus 1 gets cancelled, and here you will be having reciprocal of n plus k. So this is your kth term. So in the place of k you will be having 1, 2, 3, so on and so forth. So now I can write the entire question as limit n approaches infinity, summation n equals 1 till 5n, because I am having 5n terms and the first term starts from 1, reciprocal of n plus k. Alright. So now we are going to convert this particular summation, or say this Riemann sum, to a definite integral. So before that, let me simply remove n from the denominator, and if I remove it, I'll be having 1 plus k by n, and here I'll be having 1 by n. So now we are going to use the formula which helps us to convert your Riemann sum to a definite integral. Which can be stated as integral a to b f of x dx is equal to limit n approaches infinity summation k equals 1 till n f of a plus k times delta x into delta x. So here we are provided with your right hand side and we are asked to find your left hand side. Now the technicality over here is to find for a, b and f of x simultaneously such that the equation holds true. Now let me first find your delta x, alright. So let me say that delta x, so your delta x to be 1 by n. The usual delta x formula is given by delta x equals b minus a by your number of terms. So here also I'll be having b minus a. Your number of terms is 5n. So let me write 5n over here. So your n gets cancelled. So b minus a. So the difference of b and a is 5 is a hint that we just got. So it has infinite many solutions, right? So I can also have a to be 0 and b to be 5. I can also have a to be 1 and b to be 6. There are so many different possibilities. So we'll have to proceed with any one of the possibilities such that the result holds true. That is what matters at the end. So now that we have taken delta x to be 1 by n, f of, let me now compare the term which is next to delta x, that is your f of a plus k into delta x. In the place of delta x let me write 1 by n, and in the summation we are having this one which is your 1 by 1 plus k by n. So in order to find the k, I'll have to make another assumption which is for your a. Now a can be assumed anything, but we are going to assume a such that your result is going to be relatively easier. So let me assume a to be 1, right? So this is my second assumption that I am making. Now if I do so, your f of a, in the place of a I'll be having, if I do so, in the place of a I'll be having 1. So f of 1 plus k by n would be equal to 1 by 1 plus k by n. Now the function's input is 1 plus k by n and the output is simply the reciprocal of it. So the function is simply a reciprocal function. So f of x should be reciprocal of x. So now a is 1 and f of x is 1 by x and your delta x is 1 by n. Now it's time to find b. As I already mentioned, b minus a is equal to 5, and since I've mentioned a, b minus 1 is equal to 5, so b would be 5 plus 1 and it is equal to 6. So b is equal to 6. Now my point is to write your Riemann sum as your definite integral. So which is integral a to b f of x dx can be written as integral 1 to 6 f of x is reciprocal of x dx. So integration of 1 by x is log of modulus of x 1 to 6. This now I can do the upper limit substitution minus your lower limit substitution. I'll be having log 6. So this is your answer. So we are also having a different way. It's not like this is the only way. I can also assume your a to be 0, alright, and if I do so, f of k by n would be simply 1 by 1 plus k by n. Now my function f of x would be 1 by 1 plus x, right? Because your input is over here, so your function's nature also has to be in such a way that it should be 1 plus your input. So f of x would be 1 plus 1 by 1 plus x. And now your b also changes because your b minus a is equal to 5, and if I take a to be 0, b would be equal to 5. Now the integral can be written as 0 to 5 1 by 1 plus x dx is equal to log of x plus 1. So 0 to 5, and this should be log of again 5 plus 1 minus log of 0 plus 1. So your answer would be again log 6. So the point is that a, b, f of x has to be set simultaneously, and there is no unique way to do it. You can do it in different ways. But at the end, the formula or the conversion must hold true. That is what matters at the end. So I hope you learned something new in this video. Follow and subscribe us for more such content. Thank you.